Hello everyone and welcome back. Like I mentioned in the previous video, we are going to discuss one of the most important topic in SQL or I would say data engineering or analytics because that skill will help us to dissect our problem into small pieces, and then we solve these pieces and then integrate them together to build the final solution, which is a common practice in doing or building any software engineering work. So the same practice apply in the data and analytics development, and so as on data engineering. So now after this topic we might slowly start moving from intermediate towards the advanced. So make sure you have enough practice. You can get the online test questions, and you can see that if you can resolve this question through the skills that you have learned. If you are not clear, you can revisit the video, or you can even put the comments. More than happy to answer for all the analytical related queries. One more thing, that the same concepts are going to apply in the Spark SQL. So keep in mind, whatever you are learning in here, you will apply with minimum changing on the Spark cluster. So in other way, with one skill, you're gonna actually be a master of multiple technologies, regardless of the size, right? Because obviously in the Spark or in the big data environment, we have a different sort of challenges. But to tell you the truth, most of the time you're gonna be survive, because the skills to build the script that can extract, that can change it, that can prepare the data, and then the rest is more like pre-built algorithm that you need to learn how to use them, how to pass the data set and extract the value, and then pass these values to the final destination. That can be another database, and that can be one Spark database where you can store these values. And then the data analytics team, if they are separate from you, they can make a connection, and they can read those connection and spin up a good dashboard, right? So that's normally the model that works in most of the enterprises. But if the enterprise is small, what normally happen, they put multiple hats on one person. So maybe you're the guy who's building the data pipelines, who are building the integration, you are building the data storage stage, you are building all these data sets, or script which is preparing these data sets, and you are also building the dashboard for the business, so you can see the trends and you can see the outcomes of processing the data, and apply the rules based on the given business logic. So that always come as a package as well, and depends upon the organization side. If organization is really big, then they have multiple teams who look after different area. But keep in mind, now these skills which are now you are going to learn, especially from join onward, they are extremely important in terms of becoming a master of data engineering. And tell you the truth, I know that at some stage we're gonna look deeply in Spark, not only Spark SQL but also PySpark, because maybe some people think Spark is a bit complicated in terms of their syntax, and it is. I'm not saying it's not. It is some areas. Spark is very complicated from the syntax perspective, and thankfully we have the Python as well available as a wrapper we can use. So that's something which is amazing only in Databricks, or I would say in the Spark, that we have multiple flavors available. We can use one of them interchangeably to do the job, right? And that's where Spark or Databricks shine. But obviously we'll see once we reach there. Let's come back towards the today's topic, which is subqueries and common table expression. So now obviously the name is showing that whenever we need to write a query within a query, that is called the subquery. So you can see a diagram in here. We have a main query, and in that main query, we have a subquery. And by the coloring, you can see we have a different, obviously, logic between the subquery to the main query. And it's not like it can only be a one nested level. It can even go further, like you have a even subquery has a further subquery in it. It all about it's all about how you want to how what are the business requirement, how you are actually going to address those requirements. And tell you the truth, that's one of the most powerful skill and concept in the SQL. Like you break down your requirements, and you start building with with the minimum or from the bottom to top. And once all these bottom pieces have been built, you just need to connect them together, and voila, your final output is ready. So that's what we call a subquery. What could be the scenario we're gonna see in the demo environment? So common table expression is another, I would say, technique to use the subquery. In this in common table expression, what we normally do, we build our temporary query, and then we use that query for to join with other table. So it's also called the concept is similar, but it's more like a temporary expression or temporary output that you can use for your further work, right? So common table expression more like a temporary table. Let me put this way, instead of creating a temporary table and then use it, if you want to use a temporary table on the fly in your script, you can use common table expression, because these common table expression will give you the output based on your condition or your business logic in a temporary format. And then you can reuse that output to maybe to join it with another table to get the final output. And that's where the common table expression really shine, because they are very efficient. You can filter the data, and you can apply all sort of the logic in your selection query, and then you can label it with a name which is more like the table expression, and that name you can use in the query further to generate the next level of output. And then obviously now I think you can understand, we keep going with this until unless we reach to our final output. Really depends upon what kind of logic you are implementing. Tell you the truth, it can be a very simple logic, or it can be one of the most complicated logic in your script, right? I have seen both in my experience with all kind of industry. We have seen some really complicated nested query that have been built, or we have built it by ourselves. All you need to do, look, like I mentioned previously, power comes with great responsibilities. Subquery is a very powerful tool. If you start using it, make sure you have a proper documentation and you are using it in an efficient way, that later on, once you visit it after 1-2 months, you still remember that what you have implemented it. So enough theory, like I mentioned, let's jump into the demo environment, and we're gonna write our subqueries today. Okay, so let me first explain the scenario so you can understand what problem we are going to resolve, and it will help you to understand the usage or the concept of subqueries. So I have a book rating table. If you remember our data set, let me first show you if I can, what I can do. I don't have it in here. Okay, I'm going to put it in here. And by the way, do I have a diagram? No, I don't have it anyway. What I'm going to do, I'm just going to show you a quick schema of our feature set, which we are using so far. Just let me put the page break so I can see my tables. Okay, my tables are good in a shape. So let me arrange them. By the way, that's more like, graphical representation of your schema that really help you once you are designing or once you are understanding the relationship. So you can see I'm just putting these table in a way so I can understand the true concept. So I think we are good here. Just bit aligning them here. Oh, sorry, I think I put it the other way around. Yeah, table rating is going to be in here and it's going to be in here. All right, so we have the table rating. It's a recommendation system that we are eventually going to build. It's a machine learning system that's going to see what user has been rated to books, and then we're going to use machine learning to recommend the student, the user, some other books which we believe are going to match with their interest. How we going to do it? That's all later videos. Right now, let's only focus on preparing the data set. Now, once we come and we start building the data set, you can see that obviously we need to check the total number of rows, or the data set is complete, the data set is accurate before we feed into the machine learning model. And that's where you remember my statement that machine learning itself is more like an algorithm, and our smart brains in the industry, and especially from these big research center which are running by Microsoft, Google, and Facebook, and all these research center, they have already produced some of the best machine learning algorithm for us that we can reuse it, right? So don't think of reinventing the wheel. There is no point. Right now, the more challenge is to use it in the best possible manner. Now, before we need to use it, the machine learning, we need to make sure we are feeding the correct data, right? Because if you are feeding the garbage, you're going to get the garbage, right? If you are feeding the wrong information in your machine learning model, it's not like, a pure human brain who can, sense check and you can identify, yeah, that looks right, that looks wrong, right? Because first, we don't have such a big data set that we can use to train our machine learning a model in a way that it can fix everything, right? Because it needs example, it needs the test data sets, and those test data sets literally refine the machine learning model, right? So that's why we need to focus a lot on preparing the data set. So once we feed it, it will increase the accuracy of our machine learning algorithm or model. Now I'm going to actually show you today a couple of challenges why the data scientists even now feding up with the data science field, and they are moving towards the data engineering. There are reasons. You can see the table structures are pretty simple. Like we have three tables. In one table, we are collecting the book rating. In the other table, we are collecting the user. And in the third table, we are collecting the books, like whatever book we are putting in our bookshelf or our website, which we are providing to our users for reading. And then after reading the book, the user is providing the rating, right? So which is a very simple and nice data set. Now, let me show you where the complexity starts. So what, if you remember our last video when we talked to the join, once we discussed the joining. So what I'm going to do, looks like this script has everything. I'm just starting from fresh from this one. Yeah. That was the last script that we have used. So let's continue working on this one, right? So we have the user information and the book information. What we are going to change today, we are going to change from users to books, right? And I'm just going to quickly shift everything. Obviously, the key is different. I'm just going to show you, bear with me. SPN, right? Actually, what I'm just going to B dot, yeah, okay, much better. B dot the title, right? And ISBN is already coming. Let me put one more field. B dot publishing year, right? Year of publication. Now let me run this query. We are doing inner join, so we're gonna get all the results where the ISBN, because we are joining on ISBN column. So we're gonna get the record which are common on both sides, right? Now we are getting 188,000 records. Now these numbers are very important. So keep in mind, we are getting 188,000 records. Okay. Now let me go and let me check my total record from, I just need these two, right? So, so if I run my TBL books count, I can see we have 232,000 record. However, because in inner join, if you remember, we discussed that the final output is based on the common column on both sides. Wherever they match, it returns those rows. So obviously, whatever side is minimum, that's the number of the count we're gonna get it. But what I'm seeing in here, in the book, and once I join TBL book with book rating, I'm getting 188,000. So that means, but however, I have 232,000 book record into my table. So that means there are books which are missing from the book rating table. Now that is obviously concerning, and apparently it looks like the number is high. So what I'm going to now do, that I'm going to find out that what are the books which are not rated at all, because that means these titles are sitting on my shelf. They are not attracting user. They are not providing any value to my business, and I need to do something about them. Either I need to replace them, or I need to find out, is there any particular reason why these titles are not attracting user attention. So you can see, even if you remember last time I show you, as soon as we start working, we start analyzing these things. Now the analytics start playing itself. How are we gonna do it? That's the question. So I know I need to find out those records which are sitting in the book table. So have a look how I'm translating it. I'm going to find out those records which are sitting in book table, but they don't have their presence in the book rating table. Let me repeat again. I'm going to extract those records which are sitting in the book table, but they don't have the corresponding entry in the book rating table. If you will write down that statement, that will give you the logic automatically. So first I'm going to get the, I'm a bit lazy. So I'm going to get all the records from book table. All right. So first part is done. I'm getting all these records from the book table. So you can see I'm getting 232,000 records. But my condition is, and as soon as I speak the condition, that means I'm going to use the where clause. My condition is I'm going to see those records which are not present in the book rating table. There are multiple ways to address this problem. I'm going to show you today a way that we can use through subquery. So what I'm going to do, you can see, I'm first going to write down the query to extract the record from book rating table. So obviously I need the ISBN because I'm missing ISBN value. The N from feature TBL book rating, right? So I'm getting all ISBN records. So maybe we have multiple ISBN, duplicate ISBN record, because one book can be rated by multiple users. So what I'm going to do, I'm just going to get the unique. So if you remember, we use distinct to get the unique record. So let me run it. And by the way, let me just take it out from here. So right now you can see I have two separate queries, right? One is where I'm getting all the records from book table, and the other one where I'm getting the unique ISBN from the book rating table. Now I have these two components ready. See how I have actually split the problem into two small parts and resolve it separately. Now the only thing is to join them. And that's where we use the subquery. What I'm going to show you, because we need to filter our book table, we need to filter those records which are not present in the book rating table. So obviously we are going to construct the where clause. We are going to put the column, obviously that is ISBN number, which we are going to check, and the operator is not in. By the way, let me tell you what is in and not in. If I think I remember we have discussed it, but just in case if you don't remember, let me just quickly type the person information, because person is simple. Let me see. So what in operator does, so if we provide the, so for example, I just need to get the person type, for example, and I want to get only those person where either it is EM or maybe SC, right? So if we want to, provide the list of the values in the comparison, and we just want to return those records where the condition has been matched based on only those list of value, that's where we use the in operator. So what does it mean? It's going to actually check the person type in each record. If that person type is in the list, like whether it's going to be EM or SC, then that record will return. If it is not in the EM and SC, the record will not return back to us. And we can flip it, like we can apply the not operator, which what it will do, it will reverse the, or it will return us the opposite output. What does it mean? We get all the records where the person type is not EM and SC. And let me run it again. So you can see we are getting SP, and then we have VC, all the other type, but we are not getting EM and SC. So these are the two operators we normally use, if we have the list of value, instead of, one value for the comparison, if we have multiple value, then we will use the in operator. And let me just now take, because we have seen the concept of in, and I'm just going to make it dynamic. So for example, let me put this way. I'm not going to provide the hardcore value. What I'm going to do, that will be a subjoin. I don't want to do it in this way. So let me just keep it here. I will discuss it in the self join. Don't worry about this. I don't want to mix the concepts. Let's leave it for a time being. Let's come back to our actual query. So now we understand in and not in operator. Let's rewind our logic. We are going to extract all the ISBN number, all the title from the book table, which are not in the book rating table. So now you can see now where ISBN, which is coming from the book table, not in, and that's where we provide the subquery. So in these small brackets, we provide the query. So what it's going to do, it's going to actually return all those ISBN which are not in that list, because the inner query, how it will work, the inner query will generate the result. So for example, the list of unique ISBN in the book rating. So you can see we have all these unique. So now you can see the number has been dropped significantly from book rating table. We have 340,000 records in the book rating table. What we are going to do, we are going to now find out what are the ISBN from book table, which are not part of this list, which we are getting from book rating table. Now let me run it. So that means we are getting a lot of records. You can see we have all these records which are coming on our screen. And it is running because not in, keep in mind, I would say expensive operation. Try to avoid it. I'm just actually showing you the example. There are other ways, the way we can actually do it. I'm actually going to show you the other way as well. Why it is running and it's taking some time, because we have over I think 100.13 million record in the book rating table. So that's why it took a little while to extract the result, right? But now you can see we have 169 668 records, which are not part of book rating. So you can see literally half of the table of the, or half of the titles, they were not rated by the user. So that's not even I would say that's not even a surprise. In day-to-day life we see these kind of scenario. That's why the data is so challenging, that as soon as the volumes grow up in the data, we face more and more challenges, in terms of quality, and in terms of the cleanliness or completeness of our data set. And one of the example you can see now, all these title, none of the user have ever read, and they are sitting on my bookshelf. Maybe I'm paying some sort of, a royalty, or maybe I'm paying some sort of fee to keep this title into my online bookshop or into my portal. And now imagine they are not returning me a single penny, because users are not rating these books, and that's why they are more like, a static asset, which is now turning into a liability to me. So now you can see how I'm actually using subquery concept to extract that information. All right. So now that's something we have find very useful. And obviously our executive team, they're gonna be very happy with us. Maybe you get a promotion. I'm just kidding. So because we have identified something which is really great, and that can really help the business to change its direction and find out, okay, how they can improve the user engagement while they are reading the books. They can provide, the rating, or they're going to investigate these title why they are not been rated in the past, not even once. All right. So that's one use case. Now, what I'm thinking for another use case, which I think which is going to be interesting. Let me reveal it to you. For somehow, it feels like I don't have the right result when I'm actually joining the book table with the book rating table. And why I'm saying it, I'm just going to actually show you. I'm just actually working out what's the way I can, I can get the value out of it. So let's run it again. Let me run the above query again. So we are getting 188,249, right? And if I actually show you, yeah, I think that's a better use case. Let me quickly confirm that, do we have 188,000 title into our table? No, we have 62,739 title into our table. So that means some title has been repeated. It might not be a good scenario. I don't want to bring some additional concept at this stage. Let me see if I can find out, Okay. Yeah, I think we can do another one. Okay. So that's we check, and now that's all part of the data preparation exercise. So we first check the title which are not sitting into our book rating table. Now, what we are going to check the other way around, we are going to check, is there any title which is sitting in our book rating table, but they are not actually part of our bookshelf? Because if that's the case, that is going to be a problem for my analytical dashboard or reports, because they are not going to be picked up. Because once we join them, they are more like, there is a disconnection between books and book rating. So let's see the other side. So what I'm going to do, I'm just going to, I'm going to reverse this query. I'm just calling it BR. I'm just going to now when I don't need to. So now you can see I'm now checking the other side of the relationship. So we currently finished the link from books to book rating, and now I'm going to check, is there any title which is sitting in the book rating but it doesn't have a corresponding entry in the book, because I need to investigate those records as well. So the concept will remain simple. The only thing, the places of the table has been changed within the main and subquery. So we just put, so if I read it for you, I'm going to find all the instances of the book rating table where the ISBN of the book is not in the book table. So I'm just going to write not in, and let me run it. That means we have some ISBN, so that you can see the data is dirty all the way, right? So you can see we have the data is messy on both direction, and that's where the complication starts. And now you can understand how much struggle our data scientists put once they extract this data and then they prepare the data. And that's where the whole craziness of data wrangling and exploratory data analysis and feature sets preparation, these process comes into the picture. Because even with these three tables, you can see how much trouble I'm seeing at the moment, that both side my data is not correct, right? And I can feed that data into the model, but I might not get the good recommendation. And you can understand why I'm not getting, because half of the titles, they are not part of the rating table. All right. So let me see how many records we are getting. So we are getting 9,700, 9,000, sorry, 974,000. 974,000. And I want to show you something really interesting. In my book rating table, I have 1149780. So it means that if I subtract the value, okay, So if I subtract the value 149,780 minus 974,621, I'm getting 175,159. But there's a problem. We are getting in our inner join, if you look, that count is not matching with this number. Because if you remember, once we do the inner join, so our inner join count is coming greater than, so you can see the number of records are higher than the number of records which we are getting as a difference between the total number of record and the subtraction of these two tables. Now, let me repeat that scenario because that is very important to understand what I'm trying to find out. We have total number of record. Let me take one step. Now, that's where the SQL, data analytics skills come into the picture. We have the total record 1.14 million sitting in our book rating table. Once I identify what are the titles which are not in my book table, I have identified 974 titles were not part of the book table. So what I did, I subtract the 974,000 out of the total record, which is 1.14, and I got 175,159, which means that these are the titles which should be part of the book table. But what I'm seeing in my book table, when I join the book table based on the common condition, which is on ISBN, I'm getting 188,000 instead of 175. So the numbers are still not matching. So that means there is a problem. There is something which I'm not, which is not right in this case. So just keep this problem in your mind. I have to use it, unfortunately, in this video. So how we are going to identify? Apparently, it looks like something is not right with the book table. And the very first thing, because we are joining, so that means in the inner join, one side should be unique, the other side will be non-unique, which is obviously the parent will be unique always, and the child side will be non-unique. And that's why we established the inner join relationship. So just on the, as my first step of investigation, I'm just going to check SPN. Oh. And I'm going to use a concept which we haven't discussed yet, but please bear with me. I'll discuss it very soon. Right now, you just need to take the face value. You need to stick with it. We are going to check, is there any record with more than one instance, because we believe the book has the unique record, like it has the unique values, or we have all the unique ISBN numbers sitting in our book table. And I'm just going to validate that hypothesis by saying it. What that query does, please ignore it. I'm not going to actually explain in this video. I'm just going to show you we are investigating the data issue, data quality issue. So let me run it. And there we go. We have 283 titles which are sitting into our book table. And they are not providing, they are impacting on the relationship. So once I join the book table with the book rating table, so both tables are non-unique. Like you can see on the book side, we also have the non-unique value, like one ISBN instance is going to present for more than once. Now, how we normally resolve these things? That's where one of the technique we normally use, that's where the subquery shines again. And what we're gonna do, let me show you in here. So like you can see, I'm writing my inner join. So, instead of using this plain table, I'm just going to use my subquery. And what I'm going to do now, I'm just going to write a query. And instead of, because I'm using only these 3 columns into my main outcome, so I'm just going to tag these 3 columns. And I'm going to do one more thing. I'm going to ask that, okay, only get, and I also need the ISBN as well, because ISBN, yeah. So in the subquery, I'm not only going to specify the column, but also I'm going to mention only get the unique instance of the book information from book column, and then inner join it with the book rating. So you can see now how inner subquery is providing me the opportunity to resolve these kind of challenges where we have the duplicate records on one side and we want to get the unique instance. So now let me quickly show you the unique values. You can see the total count. We have 232, 125, which I do believe, yeah, which is way less than the total. I think we have 282 records are gone because they were duplicated. We are pretty good. Now I'm going to run this. And you can see we have 175 to 96, and that's exactly what we calculated. We did calculate, and let me quickly redo my calculation. 1149780 subtracting 974 621. So 175159. There's still a couple of records which are coming. And I think I need to check why they are going. But anyway, that's how we normally remove the duplicate records. 159 and 296. Okay, let me see. So we have these 2 totals, and we have sorry, I think that's going to be this. That's a better comparison. You can see I'm not going to use not in because there are some null values in the book rating table that's where the other side is not matching. So let me show you what I have actually done. So now you can see I have actually I put I'm just going to see that how many book rating title which are sitting in the book table, and now both outputs in the inner join and in the in operator, they are matching. Why the other side is not matching when I use the not in? Because there are some book instances which are null, so which are not even present into book and which don't have even a proper value in the book rating table. Right, so you can see the complication is going towards the next level. We are going more and more complex with this one, but these are some of the scenario where we use the subquery into our day-to-day scripts. One thing, start with small. I have because I have to show you from end-to-end solution. That's why I actually merged all this scenario into one video. But once you do it, do with this simple one and then slowly increase the complexity. But always keep in mind, whenever you are going to write these subqueries, always split it into small chunks based on the logic, solve those chunk, and then integrate at the end. That's the way we use it in all kind of programming pattern, whether it's going to be object oriented or functional programming. We always split the problem into smaller parts, we build them, and then we integrate them, and that will become our solution. So that's the subquery concept. In the next video, I'm going to actually show you how you use the common table expression. So I believe that video will be helpful, and you enjoy the demo of the subquery. Please feel free to put any comments. If you have any question, more than happy to answer. Otherwise, please like the video if you getting benefit from it, and I'll see you in the next video.